Hey everyone, welcome back to The Explainer. Today, we're doing something really cool. We are taking a massive, dense, 200-question academic test bank all about production and operations management, and we're totally transforming it. Together, we're going to distill hundreds of complex data points into one cohesive, highly practical guide to how the engine of modern business actually runs. If you've ever wondered how companies manage to consistently get you exactly what you need, exactly when you need it, well, you're in the right place.
So let's dive right in. Have you ever actually stopped to consider the journey of the stuff around you? I mean, the device you're using right now, the shirt on your back, maybe that coffee mug on your desk. Every single one of those started out as scattered raw materials. Operations management is basically this incredible chronological journey of how a business builds an engine to bring all those materials together. It is literally the heartbeat of commerce.
To make sense of this massive topic, we're breaking our journey down into 5 distinct phases. 1. Foundations of operations management. 2. Facility and process layouts. 3. The secrets of inventory. 4. Planning and scheduling production. And 5. Quality and project control.
Starting with Phase 1, Foundations of Operations Management. Before any factory can hum to life, we've got to set the baseline rules for what we're actually managing.
Our source material highlights a fundamental distinction that every ops manager has to know, and that's the difference between goods and services. Goods are tangible, right? They have a physical shape, you can box them up and store them in a warehouse. Services, on the other hand, are totally intangible. You can't put a haircut or financial advice on a scale or stick it on a shelf. But here is the real takeaway. Even though they seem like complete opposites, the core principles of operations management apply fundamentally to both. Whether you're assembling a truck or giving legal consulting, you are managing an operation.
Which brings us to the ultimate definition here. Operations management is a transformation process. Think of it like a giant transformation engine. You feed it inputs, stuff like raw materials, heavy machinery, labor, and capital, and through this carefully designed system, it converts all that raw potential into outputs. You get the goods and services that actually drive customer satisfaction. It's essentially turning nothing into something.
Moving on to Phase 2, Facility and Process Layouts. Now that we know what we're making, we have to figure out the exact where and the how. Now, what's really interesting is how companies pick their physical setups based entirely on the product itself. If you're cranking out identical items super fast, you use an assembly line, just a connected, sequential flow. But if you've got products with similar processing needs, you might set up a manufacturing cell, grouping different machines together for that specific family of parts. Then there's the work center, which just groups similar equipment together in one spot. And honestly, my favorite is the fixed position layout. This is for when your product is just way too heavy to move. Think a commercial airplane or a giant cruise ship. The product stays put, and you bring all the equipment and labor right to it. Form always follows function.
But regardless of the layout, it all boils down to the literal pulse of the factory floor, and we call that pulse cycle time. That's the average time between unit completions. Now, to keep that pulse going strong, operations managers are constantly fighting two big enemies. The sources call them starving and blocking. Starving is exactly what it sounds like. A workstation halts because it doesn't have the inputs it needs. It's just sitting there waiting for materials. Blocking is the exact opposite. A workstation stops because there's nowhere to put its finished work. Both of these create massive traffic jams on the floor that absolutely kill your cycle time.
All right, Phase 3, the secrets of inventory. Once production is flowing, you inevitably have to store stuff, and a warehouse is basically an environment ruled by strict mathematical laws. The absolute holy grail of inventory management is balancing two conflicting costs, the cost of holding on to inventory versus the cost of ordering it. Our sources give us the foundational law to solve this, EOQ, or the economic order quantity. EOQ isn't just an idea. It's a specific mathematical formula that tells you the perfect optimal order size to minimize your total inventory costs. Order way too much, your carrying costs go through the roof. Order too little, your setup and ordering fees just eat your margins alive. EOQ finds that exact sweet spot at the bottom of the cost curve.
And this brilliantly illustrates how retail giants actually handle the physical stock on their shelves using the ABC inventory system. You really can't treat every item the same. Look at Class A. These are your high-value items. They might only make up 10% of the total items in the store, but they account for a massive 75% of the costs. Think of those giant high-end LED TVs at a Chroma store. You track those meticulously. Then you've got Class B, your middle-of-the-road items, like bed sheets at Reliance Mart. Finally, Class C items make up 70% of the physical inventory, but only 10% of the cost. Think hundreds of boxes of bulk soap powder at D-Mart. You put your management effort exactly where the financial value is highest. Makes total sense, right?
Let's shift to Phase 4, planning and scheduling production. We're stepping off the physical floor and into the brain of the factory to figure out exactly what gets made and when.
This whole process starts super broad and gets incredibly specific. It kicks off with Phase 1, sales and operations planning, which is this high-level 6 to 12-month game plan for the whole company. That big picture funnels down into Phase 2, the master production schedule. From there, Phase 3 is materials requirements planning, where you figure out the exact parts you need. And finally, Phase 4 is capacity requirements planning, which is where you ask, wait, do our machines and our people actually have the time to pull this all off?
Let's zoom in on that second step, the master production schedule, or MPS. This is probably the most crucial bridge in all of operations. It takes that big, lofty corporate game plan from sales and forces it into the gritty, day-to-day reality of factory scheduling. The MPS spells out the exact finished products to make, exactly how many are needed, and exactly when they're due. Without it, sales and the factory floor are basically speaking two completely different languages. And finally, Phase 5, quality and project control. So you've got the factory and you've got the schedule, but how do you make sure the final product isn't a total disaster? Let's look at how companies actually guarantee excellence. Whenever we talk about quality, we absolutely have to talk about W.E. Deming. He is an absolute legend in quality management. He introduced this famous 4-step cycle for improvement: plan, do, check, act. And this isn't just a one-and-done thing. It's a relentless, continuous loop that serves as a company's internal quality assurance system. You plan a small change, you do it. You check the statistical results, and if it works, you act to implement it permanently. Round and round it goes. So the crucial point is, what happens when a company pushes quality control to its absolute mathematical limit? You hit a very specific number, 3.4. In the ops world, this is known as operating at Six Sigma quality. It means you've fine-tuned things so much that you allow for just 3.4 defects per million opportunities. It's basically the ultimate immune system against errors, using intense statistical control to wipe out waste and guarantee reliability. Of course, managers aren't just babysitting daily factory quality, they're also running massive one-off projects. And for that, they rely on two huge network analysis tools, CPM and PERT. Now, the critical path method, or CPM, is for deterministic activities. That's just a fancy way of saying you know exactly how long a task is going to take. But if you're doing something like research and development where the future is totally uncertain, you use PERT. PERT handles probabilistic time estimates, which basically lets managers make mathematically sound, educated guesses about when a project will actually be done. But hey, what happens when a project inevitably falls behind schedule? Well, our sources highlight a pretty dramatic technique called project crashing. When delays are threatening a project, managers can't just throw their hands up. They have to make hard, time-cost trade-offs. Crashing means you literally throw more money or resources at the specific, critical tasks that are holding things up. You reduce their completion time to less than normal, and you force that schedule back on track. Your costs definitely go up, but you save the deadline. So, we've walked through the whole life cycle journey today, from scattered raw materials to factory layouts, the hidden math of inventory, master schedules, and some extreme quality control. These are the massive industrial concepts keeping global commerce alive. But here's my final thought for you to take away. These principles don't just apply to giant factories. They apply everywhere. If you were to map out the operations layout of your own daily routine, what would it look like? Are you starving for inputs? Are you blocked by clutter? Where are your biggest personal bottlenecks hiding? And how could you use these exact principles to crash your own schedule and optimize your life? Something to think about. Thanks for hanging out with me for this explainer, and I'll catch you next time.